Most agentic AI systems fail, not because of the agents itself, but because of the underlying design patterns. Of the most commonly used design patterns in agentic AI system, sequential design pattern is the most simplest one. So we will start with that. So in this video, we'll talk about what are the sequential design pattern for building an AI agent system, what are the underlying architecture, and mainly we'll talk about the core idea behind the design, when should we use, when not to use, the limitation, the trade-offs, and we'll also see some bioinformatics use case, and most importantly, we will do a hands-on where I will show you how to build the sequential design pattern. So with that, let's start. So as the name says, sequential pattern means there is a sequence. So take an example, let's say we got an input, the input goes to our first agent, and this agent is very specific or specialized agent for extraction. So let's say this agent extract the information and then pass the output to the second agent, which will transform the output, and then that goes to the third agent, which will say load it to some database. So this is a typical ETL pipeline, and then it goes to the output. So now you see there is a sequence, so three agents work together in a sequence. So this is the most simplest design pattern. So why we should use? Because the main key advantage is the predictability, because we know after 1, then 2, then 3. And this, the main advantage it provides is the lower latency than a dynamic system, because in a dynamic system you don't know how the system will behave, but here we know that after step 1, step 2 and step 3 happen. So that's why the latency is lower, and similarly because of that the cost is also low, because there is nothing randomness is there, it is behaving the way you expect it to behave, and that's what the predictability behavior is the most advantage of that. Again, the important thing is also the troubleshooting, because if your pipeline fails at, let's say, step number 2, then you can easily troubleshoot, because you know that after 1, 2, then it failed itself, right? So when should we use? This is useful only when your workflow are structured and repeatable, because if you have a use case where you know that after this one, this step, this step, this step, so there is a sequence involved, if that kind of use case you have, then you should go for it. And the execution order rarely change. And next is consistency is more important for you than flexibility. Then you have to go with this kind of design pattern. So commonly example pipelines are the ETL pipeline, or let's say document processing example. Let's say you parse the document, analyze it, summarize it, and store it. So these kind of examples we can use. Now the main limitation of this kind of workflow is that it cannot adapt mid workflow. Let's say there is a sequence 1, 2, 3, 4. It has to go that way. It cannot go 1, 2 and skipping 3, then go to 4. It cannot happen. It has to flow. It goes through the 1, 2, 3, 4 flow only. That's the main limitation. And all the steps execute even if some are unnecessary. Let's say in your pipeline you do not want 3, but because it's 1, 2, 3, 4, it will go. The third step will be run. Even if it's kind of unnecessary. That's what if step 3 is unnecessary for certain input, agent still executes it. So that's why it will waste your token. It's wasted compute and time. So these are the main limitation. So that's where you have to decide whether you will want to go for the sequential pattern, or let's say maybe some intelligent proper other alternate design as well. So let's take an example of our bioinformatics use case, the famous like the QC NGS QC analysis. So let's say we have a agent which is very expert of doing QC, quality check analysis. So your data goes, and this agent will do the QC, then it goes to the second agent who is an expert for pre-processing, maybe adapter trimming, and let's say quality based trimming. This agent is specialized for that. And then maybe you are using the same agent after pre-processing, want to check the QC, then goes to the alignment agent, which is specifically expert of doing alignment, maybe RNA alignment, DNA alignment. It might use, so you can tune which tools to use, those kind of thing. And then we have an agent for alignment QC. So in this kind of workflow where we have a specific order, we can use this. And most of the bioinformatics pipeline are generally follow this kind of workflow, and we should go with the sequential design pattern. Some other examples like the same extending to the alignment, you can go for quantification, differential expression, and doing the final report. Or maybe let's say if you are doing some functional annotation analysis, so given a protein ID or gene ID, you can go for sequence retrieval, then doing a blast search, then identify the domain and do some functional annotation, and finally you store the results in some database and render the report. So there is a steps involved. So let's say another example in clinical report generation, let's say you have identified the variant, then you do annotate it, then you do some interpretation and finally format it and you generate a report. So you see there is a sequence of event involved and we can connect it. So with that, you've got an idea, like you have, and you can easily build a sequential design pattern when you know the your workflow follows a definite sequence. So with that, let's do a very quick hands-on where I will show you how to build this kind of agentic system. So I'm opening my Visual Studio Code and I will be using OpenAI SDK agent to build the framework. So if you're not aware of this, I had already created a video series on creating simple agents using OpenAI SDK agent. Please do watch that to get an idea how to build it. But still, I will give you an overview of the code, like very simple code. Okay, and all these codes are available in my GitHub repository, and the GitHub link is also I will put in the description for you. Okay, so let's begin the use case. So it is in Python, so we will first import all the libraries. So what libraries we need, like for OpenAI SDK agent, we are importing these agents and runner from these agents, and I'm also loading in my environment where I have stored my OpenAI key. So that's what I have loaded it. Now here, in this example, let's say we have two agents. The first agent is an agent whose expertise is extracting the gene names. So how we are creating, we are giving this agent the name, we are giving gene extractor, and we are giving the system prompt or the instruction to this agent that extract all the gene names mentioned in the given biomedical text written as a comma separated list. Basically, if we give this agent some text, it will extract the gene names comma separated. And here we are using for now GPT 4.1 Nano LLM model from OpenAI. So this is how we define our first agent. So now let's define the second agent. So this agent, let's call that annotator. So this agent, we are giving the prompt that it will now take a list of gene names. So basically this is the gene names what we got from here, we will feed it to here, and what given instruction we are giving, given a list of gene names, your task is to provide a brief biological function for each gene. And here I am explicitly stating 15 words or less, because this agent, this LLM model, they are very generous to give more output, summary of output. But the problem is like more output means more tokens and more you will be going to pay. So in order to restrict for this trial purpose, you can just add some word like just answer in 15 words or less. That way we can consume the less token. Okay. So anyways, so here I have just defined two agents. Now we will connect them. Okay. So that's what here I am designing a workflow. So this is simple Python function where we will text a query, the text, the biomedical text, and first we will call our first agent. So here see we are calling runner.run, and this is here we are passing our first agent, which is the extract genes agent, and here the text what we receive that we are passing here, and we will get the results from the agent, and then we are gathering the final output, and this is where we are printing the gene list, because this agent output what we get is the gene list. Now this goes to then next we are calling the second agent, here the annotation gene agent, here we are passing this gene list over here, and we will get the output, and we are just returning. So here we are defining a function, and here since it is a asynchronous function, we have to define in that way. All this agentic AI framework works in a async manner. Okay, so let's define the pipeline, and this is what we will be executing. And here for execution, I am just giving a trace so that all the execution of this pipeline will happen within this trace. We can easily, so let me change the name for now, just because I had tried earlier. So here I am giving the question that BRCA1, TP53 are the important genes in this biology, and EGFR. So ideally we have 3 gene names in the text. So let's see how the agent will work. Okay, so I'm just calling this. So now this will now send the request to the OpenAI, because that's where we have defined the model. So I will now go to OpenAI. Okay, and this is the logs here. If you go to left hand side, we'll get the logs, and so let it open. I'm going to the traces here, and so this is the pipeline, sequential pipeline demo. So I'm going here. So let's see how the agent works. Okay, so you see first it called the gene extractor agent, and if you click here the response, you see this is the system prompt we gave, what it has to do, and this is the user query we gave, and now you see the output what we got like BRCA1 TP53, because this will give the comma separated. Now this goes to the second agent, that is gene annotator. It took the input as this one, and it gave a output like this, right? So this is how we have connected two agents together in this workflow, and you see the output what we got, like extracted genes are like this, and BRCA1 does this, TP53 does this, EGFR does this. So this is how we have created very simple step. We imported the library, step 1. Step 2, we defined our agents, and then we are creating the pipeline, step 1 and step 2, and inside a function, and basically we are calling that function over here, right? And similarly, also this is a very simple agent, but you can empower this agent further by connecting it, providing it some additional tools, or maybe connecting to some MCP servers, and many things you can do. But the system, the connection is like, after first agent you call, the output of that goes to the second agent, and that way you can connect the overall system. So that's how like this system talks about, like, how the sequence goes. Yeah, so in the next, this is what about the sequential we saw. Now the next is a very another reflection design pattern called reflection design pattern, where the same agent will behave in two mode, one the generated and critic mode. So this is a very interesting pattern that we will see, and we'll do hands-on as well. So please continue to the video. I hope this video was useful, and if yes, thank you so much for watching this video. Thank you. Bye.